We'll give it 5 and then we'll kick things off.
Perfect.
Hey, Stephen. We're just giving it a few minutes for people to join, and we'll be kicking things off at 5. Well, 5 minutes after.
Gabriel, I mean, if you could just let us know maybe a few minutes in how many people are there, uh, that'll really help us. Kind of, we have like a back plan to use a Slido if maybe we won't need it, because we can just have questions here in chat as well. So
Okay, yeah, absolutely. Oh, and the recording's on, by the way.
okay, perfect. Yeah, thank you.
All right, one more minute and we'll kick things off. And for all the attendees, we encourage you to come off mute and ask questions. This is supposed to be an interactive event, right? So if anything comes up that you want to talk about, there anything in particular, any kind of questions you may have, feel free to unmute, let yourself be heard, or throw your questions into the chat. We'll be monitoring it throughout the event. We can respond to you there too. All right, so let's just go ahead and kick things off. First and foremost, thank you all for joining us today. My name is Gabriel Batista, and I'm a solutions architect here in AWS. For June's AWS for Games Builder session, we have our partner Cockroach Labs come in to talk through their database offering and what it looks like to actually integrate it into a game and use it for your current workloads. So with that, I'm going to go ahead and kick it off to David. Again, thank you so much for taking the time and putting this together for us. Over to you.
All right. Thank you so much, Gabriel. Everyone, thank you so much for joining this builder session. My name is David Joy, and today we're going to have like an hour, 1.5 hours of talking about CockroachDB and AWS in game tech. And as we begin, I'm really cognizant of the fact that you have taken 1.5 hours of your life to come here and learn something new. So we hope to keep it interactive, keep it in a way that you're able to cope up with what's going on, and also have a great interaction with us learning CockroachDB and how it can influence the use cases in game tech. So the builder session team today, we have a bunch of us from our team. There's Jeff Carlson on the call, who is a senior manager and for our channel sales engineering team. and Jennifer Casey, who is our AWS Alliance Manager, Harsh Shah, who is Channel Sales Engineer with Cockroach Labs, and me, who is also a Channel Sales Engineer, but I'm focused on AWS. And when they come and present, you will also get to hear from them and what they have been doing. A few things that we wanted to kind of help you understand is the objective of today's session is to help you learn and experience CockroachDB so you can understand how it can help gaming and game tech use cases. And we want it to be an interactive session, but at the same time, we don't want it to be a knowledge dump. Rather, we want you to really experience the product that we have by actually doing some hands-on exercises. We also have an actual game that we created that runs on AWS and CockroachDB and a game server for you to actually play around with today towards the end. So we'll have a lot of fun trying to do all these different activities. So at any given time, if you have any questions or any thoughts, feel free to share it in the chat. But a few other housekeeping items are with respect to the agenda is what we're going to do today in the next 1.5 hours, and we have added some buffer if you want to unmute and have some conversations with us, is we're first going to do a CockroachDB overview. And then from there on, we'll talk about why CockroachDB and AWS for game tech. And then we have a few hands-on sessions in the form of a module where we first get to set up a CockroachDB cluster and monitor it. And then we're going to go into some essential fundamentals of CockroachDB, and followed by another module of trying on transactions in CockroachDB. And then we'll take a break somewhere with Q&A in the middle, but you can continue to add your questions on the chat. And then we will talk about distributed transactions in CockroachDB as to how do we handle these distributed transactions, which is going to be led by Harsh. And then we will have a module 3 where we actually will get to bring down a few servers of CockroachDB and see how it all works without any issues. And again, you can see how resiliency works with CockroachDB. And towards the end, we will get to play the game, as I was already alluding to. And we also have an opportunity for you to win a $50 DoorDash card by playing a simple quiz by just being attentive and interacting with us. And towards the end, I'll have Jen come in and talk about some call to action items around how you can interact with our team and places where you can go learn. All right. So let's begin with like a few other housekeeping activities. We are going to use this platform called Killer Coda, which is an interactive hands-on environment where you can actually follow the instructions and kind of try the product itself. It's basically a notebook built with a terminal. So you get to use that. We are testing this out right now. So if you have any issues, just let us know, and Harsh and Jeff and I will help you kind of navigate it. We will also demo the interactive environment and how we are doing the module with you. So in case you are in a position where you don't want to try it, you can actually learn by watching.
Sure. Hey, can you get that? So yeah, let's start with the overview. So basically, I'm just going to cover really around the architecture, and then subsequent slides that David and Hirsch are going to cover really dives a little bit deeper with regards to what's special about Cockroach. So let's move to. So yeah, so what is Cockroach? From a high level, just we take what developers have come to know and love with the relational database. So the ANSI SQL, the familiarity, we provide the ability to scale very either horizontally or vertically. And this is a flexibility that you see in databases like Cassandra and such. But what they do, what Cassandra does, is it actually it forfeits a bit of what you expect from a relational database, like being able to join tables and things that people have been able to get used to for relational databases have been around for about 40 years. And add on top of that, the ability to elastically expand on the cloud and be able to do multi-cloud or hybrid cloud implementations is important. So I'm going to dive in a little bit further. So next slide. All right. So typically, I like to use this slide is that you have scale fast, survive anything, and thrive everywhere. Really good marketing terms, but we'll dive into each one of those as to what is special about Cockroach with regards to each. David, if you could go to the next one. So Cockroach is it's a SQL database, right? Much like Oracle or SQL Server, and we utilize the Postgres wire compatible protocol. And really that just means that you're able to take advantage of all the tooling that's been built up over the 40 years that Postgres has been around and be able to implement relatively simply. Now, the easiest way to look at it is that we're a serializable isolation level database, and each node acts as a gateway into that database. And sorry, you moved back. So basically, the easiest way to look at it is that you have a collection of nodes that form a single logical database. Now, next slide, please. So if I want to scale up that database, it's as simple as pointing a node at the cluster, and that node immediately is brought into service. And just to clarify, a node is contains compute, storage, and memory, right? So when I say it immediately starts serving traffic, it's going to handle reads and writes, as well as behind the scenes, the cluster is going to follow the heuristics of ensuring data survivability. So every time you add a new node, it's going to balance data across. Each node is a gateway into the entire cluster. So if you connect to a node, it's going to allow you to be able to get the information. And what's kind of neat is as you start adding nodes and as you start building out and going into a multi-region context, it allows you to, now you're going to follow additional heuristics that allow you to, as you load data, to have data survivability goals. So if you lose a given region or so. So as you load data, so if I'm loading data into the East Coast, the cluster is actually going to co-locate the data as close as possible to my activity. So that gives me basically local latency. But additionally, it's the so additionally what is so right. So when we load data into the cluster, it loads it it stores it in a lexicographically ordered data set. And we use RAF protocol. And what RAF protocol will do is basically, as a default, creates 3 copies of the data when you're writing into the database. So in the case of a multi-region context, we're going to load into, say if I'm doing my activity on the East Coast, which is where I'm located, it's also going to make copies to the Central and West. And it adheres to, so as part of RAF protocol, you adhere to quorum. So once a copy is actually written to Central, quorum is satisfied because we're going to make 3 copies. As long as 2 of the 3 have responded that the data has been copied correctly, we're going to respond back to the application that has been successful. Now, what's kind of neat about this is also each replica is stored essentially at 512 megabytes. So the significance of that is that when you need to when the cluster needs to move data around, that data set is large enough. And when I call the 512, it's actually what we call a range. So it's large enough that it actually can move the data around to balance as new nodes come on, or we might want to downgrade the cluster and shrink the size of it. It moves it around fast enough. It's large enough to do so, but small enough not to impact performance. So we've actually tested it out quite extensively. Now, and think of ranges as like, I usually use the analogy of an alphabet. So you've got the lexicographically ordered alphanumeric, A through Z, and then when I'm loading data, A goes on the East Coast, B is in another node, but you're gonna have a copy of that A on Central and West. And the significance of this, and David, can you go on to the next slide? Thank you. So the significance of this is that you're able to survive any sort of reasonable failure event. And how we scale up the system is a cluster is essentially the same way we scale down. And in a traditional setup, you have an active passive configuration, right? Typically, the active node is doing the lion's share of the work, and the passive node is waiting for the active node to fail. And then when the active node fails, there's some sort of interruption in service, right? So your RTO and RPO actually are measurable. So it could be in systems that I've worked with, it could be 3 minutes. And then I had one customer, it was actually 3 hours. So those kind of interruptions in service can be very impactful to your business. So when we actually lose a given node or a given region, what happens is that the other nodes take up because you have data survivability goals, you have multi-region, your copies of the data in central and west. So if we lost the East Coast, central is going to take over being able to handle the query load. So these are things where you're able to see minimal impact to a 0 RPO. And additionally, this allows us to be able to do other things like be able to upgrade the system without taking the database without taking it offline, and also be able to do changes. So if going back to the multi-region context, we can start our cluster, our database as a few nodes, but then we might want to build it out into a multi-region setup. And we could do that without actually ever taking the database offline. So those are important things. So that way you're able to stay online and operational, hence Cockroach, right? That's why we follow that mantra. Next slide, please, David. Thank you. So I've already touched on this piece a bit about being able to thrive everywhere. And the importance here is that the cluster will move around those ranges to both make sure that each node each region in this case is following the heuristics of survivability and also performance, right? So being able to co-locate data as close to the user or the application as possible, so you get that local latency. Now, on a globally distributed database. Additionally, we've taken this a bit further and allowed people to be able to do data siloing. And data siloing has been more prevalent in usage over in EMEA, in Europe, where they have to follow more around the GDPR, right? So they have to be, if data is actually created in Germany, it has to stay in Germany. So you could have a database which has 3 nodes in Germany, and you could indicate that those nodes, any data coming from Germany needs to stay in Germany as well to adhere to data siloing requirements of GDPR. We're also seeing that a little bit in the US around gaming, because each state has different rules and regulations, and there's some GDPR-like regulations for certain states around gambling. So I've actually, next slides. I believe there's one more. I'm screaming through this. So, and anybody, if you have a question or if you have anything you'd like to discuss that I've covered so far, just please chime in. And what I'd like to point out is that we basically have 3 ways you can utilize Cockroach. So showing you the architecture as I did, that's essentially self-hosted, right? So that's basically, you might want to roll it your own on-prem or in a hybrid configuration on-prem and cloud, or private cloud and public cloud. Or you might want to do something a little bit where you're actually running on AWS specifically. We also do push out, and we're able to deploy as a multi-cloud. So we tend to be very platform agnostic and flexible. But if you don't want to deal with the administration and the build out yourself, you could deploy dedicated, where we're handling your cluster on, say, AWS, right? And we do all the the maintenance essentially, and all you have to do is interact with the database. And lastly, we've provided serverless, and this is really just an easy entry point for a lot of companies where this database will scale as you do. And you start with essentially below 5 gig, it's free. But once you start exceeding that, then you can actually pay simply with some credit card. So this is that small implementation that we see people using this for and such. So that's basically covering what we offer and how we deploy on this. So does anybody, I see that we have 4 people on, anybody have any questions around that? Stephen, Matthias, or Jack? I'm going to assume nobody coming off mute is a sign that you're good. So cool. I think that is the last slide. I blazed through it, said a lot of blather, but then we're going to move on to the next section of this presentation.
Awesome. Thank you so much, Jeff. So just a few things from what Jeff was saying. The 3 things we want you to kind of understand right now is when you think about CockroachDB, right? We want you to understand that we are a database that enables, folks to scale fast, survive anything, and thrive anywhere. Now, the question is, why does CockroachDB for game tech make sense, right? Like, what's the whole point? And so let's cover that, right? So when you have a game, and I'm an avid gamer. I play FIFA online, and I get beat by a bunch of 14-year-olds out of Mexico and Canada. When I was playing the game, I realized, why is it that I always get first playing against people only in Canada and Mexico, or people in the US? It's because what the algorithm really does, or the way they've designed it, they want to create a situation where there is low latency experience, that I don't have to have network hops. But the other thing is, like, say you are a gaming company and you are trying to create a global real-time multiplayer multi-match experience. The scale at which you're growing is critical, right? So you will have a bunch of users or gamers joining you from joining the game, say in the US, and the game really connects to a game server, and that game server now needs a distributed scalable database, so that you have some of the things that Jeff shared just now, the ability to scale fast and to survive downtime, as well as to have data close to where you need it to be, and have the real capability to thrive anywhere. But this is not how games are scaling nowadays. You also have scenarios where the same game is expanding to different regions, let's say Europe and Asia. And so this is a moment where you really have to start thinking about, when you're designing games, how do you handle scale? And how do you survive anything? And how do you thrive anywhere? So in that context, we feel that CockroachDB provides an amazing option by providing a distributed scalable database, which is actually consistent, yet at the same time provides capabilities of scale and high availability. Now, these are some of the challenges. Whenever I've had conversations with folks in the gaming space, and I have some friends who are game builders, we talk to them about the new challenges in 20 since 2020, of what it looks like with respect to with the development of e-gaming and other use cases within game, because even a game is no longer just a game, it's also a e-commerce platform where they're purchasing skins and other you're having transactions, all of that happening from within a game. So it's no longer just an experience where you are playing a game and trying to complete an objective. So based on some of those conversations we have had, we have realized that for game tech, especially scaling based on demand and maintaining high availability, serving a global customer base, or guaranteeing consistent transactions and navigating complex regulations, say when you are in Europe or Asia or in the US, these are some of the high level challenges that some of the conversations have led to. And of course, there are some other challenges. And now, what we want to reveal to you is that when these challenges are coming up, we as a company, and what we do with CockroachDB, is how you can address those challenges. And this goes back to what Jeff just shared with us, where if you want to scale, CockroachDB allows you to scale infinitely, as long as you know how many nodes or servers you want to add to scale that requirement. Every element of this challenge is actually and can be handled by CockroachDB. So if you want to maintain high availability, the way we distributed data, the way we replicate the data enables that experience. So as we go into the second part of the overall experience that we are going to discuss today with CockroachDB, you will see how we are going to address these challenges. Now, we want to take a pause here and bring a real example of a company who was trying to solve these challenges and reached a point where they almost had 8 million monthly active users and was struggling with latency issues. They had limited support on transactions. They were struggling with scale. They needed data to be consistent, and they needed a database that could do heavy write transactions yet be affordable at the same time, right? And that was the experience. Those were the requirements that they had, and this was Dev Sisters, and the game is actually called Cookie Run. Kingdom on, and that actually runs on CockroachDB today. And because of the kind of challenges they have today, they run CockroachDB on AWS with their Cookie Run game, and almost 10 million downloads of the game happened in the first month after they scaled to CockroachDB. So we really wanted you to kind of understand how we are actually enabling enterprises to scale out their games and other game tech use cases. So this case study will be shared with you, so you can actually read it in further detail. And with that, let's move into our first interactive session, which is where we actually are going to go to Killer Coda, and then we are going to create a CockroachDB environment. We'll set up the cluster, and we'll actually observe the cluster as it is. So what Harsh has done now is shared with you a Killer Coda link. All you have to do is basically click on that link, and that's going to take you to this page, which is available. I'm just going to refresh my screen because I was testing it out before I joined the call. All you have to do is create an account with your Gmail or your GitHub or whichever account that you prefer. If you don't want to create an account, you can just see what I'm doing here and kind of experience the same thing as well. So again, the objectives here are to, for the first module is to set up a CockroachDB environment and observe it or monitor it through the monitoring console that we have, which we call database console, DB console. So here, in the first part, what I'm going to do is I'm going to download the CockroachDB binary.
Yeah.
So we're going to
Let's
yeah,
just take a pause for 1 second, make sure people are up to speed.
Yeah.
If people who want to join in are able to access the link, are they, if there's any issues for anyone's signing into the link and getting access to this environment, let us know, and from there we can proceed.
Absolutely. So we'll give a pause, and once you log in, you should be able to like navigate to Harsh's point to module 1 and just click next, and you should be on module 1 part A.
Yeah.
So if you have any issues, just post it on the chat. Yeah. Sorry, Harsh, go ahead.
No, exactly. I was just going to say that if you have any issues accessing the link and getting access to this workshop environment, let us know. If not, we'll give it a minute and then we'll proceed.
Awesome. And again, this is an environment that we found was really helpful for us to do these hands-on exercises and kind of experience the product. We are working on another environment that will be much more better, but give you a similar experience. All right. So what I'm going to do is just slowly start taking some steps. So, what we first want to do is, because we're using this is like a VM that we have, we'll set the path up, and now we're going to actually download the binary for CockroachDB, and we're actually downloading version 23.1.1. We released 1.2 this recently. So for now, we're using the old version, which will like a one version off. It'll still work. And now we're going to copy the binary and set up the path. And you should not get an error when setting this path up. And the next thing what we're going to do is just for the environment to work properly, we have to add some external libraries and make sure that they're in the right path. So that's where you just have to click on the overall command where it'll pop up like an execute. And as soon as we do that, it's kind of copying everything. And now I'm actually going through setting up the libraries and setting up all of that information in the directory. And you should not have any errors till this point. Now, once you've done that, it essentially means that you have, at least downloaded CockroachDB and everything is ready to go, at least in terms of setting up the environment. Let's just see if the path is right. When you do which cockroach, this should take you to user local bin cockroach. And now what we're going to do is we have a in-memory cluster that we can create to test if everything is set up right. So for that, all you have to do is click on cockroach demo execute. And as I do it, you will see that it's actually creating a dummy or a in-memory cluster. And then we'll just click on this select command to just see. And this time you will have to actually enter again because it's for some reason goes to the next line. And as you can see, it's able to run. So everything seems to be working fine. So let's just get out of this. And so at this point, what you have is we have downloaded the CockroachDB binary. We have everything set up now for environment. Now we're going to actually start a CockroachDB cluster. And what I'm going to do here is we're going to go to module 1B. And within module 1B, what we are really doing is creating a 3-node cluster of CockroachDB. So going back to what Jeff was saying, CockroachDB gives you an experience of a single logical database spread across multiple nodes, right? So to you, when you interact with the database, it'll feel like you're interacting with one entity, but essentially there are multiple nodes giving that experience. So here we have, we'll actually start the cluster. Because we are doing this locally, typically you would have multiple EC2 instances where you will deploy each of these nodes, and then you will bring them together within a single VPC for a single region, and you will go so on and so forth. Here, what we are doing is we are actually creating the node in the same VM. So we are going to create this node 1 with localhost 26257 with an HTTP address of 8081. So that's what we are doing, just creating one node. So we have just started the first node. And just for you to be aware of, we are starting this cluster in an insecure mode right now. In production, you will have to use the secure mode and have securities added. The listening address is where the communication happens between the nodes, and the HTTP address is what allows you to connect to the database from an external port for your monitoring and things like that. So we've just done that. There are some instructions available here for you to read. And then now I'm going to do the second node, and this is getting initiated now. Again, the second node has started. What we'll do is we'll go ahead and start the third node as well. So just note what I'm doing, because we are setting it up in a local system. What you can see here is all I'm changing is I'm changing the localhost port for listening address to 26258, and then HTTP address is 8082. For the third node, it's 59 and 83. So make sure that whenever you're setting up your environments, you have different IPs and kind of ports all set up in the right way. All right. So now we have 3 nodes set up. What we're going to do is we're going to do a first time initialization. This is what initializes the cluster and gets everything started. So now we just initialized. You can see that it shows. Let me just expand this a little bit more. As you can see, now we have cluster successfully initialized. What we're also going to do is go to the logs and see if everything is starting up well and good. So here, I just click on this. This is basically going to the cockroach.log file, and it's grepping some information to see if everything is looking good or not. So as you can see here, we have a cluster ID set up, and everything looks like it's good. All right, so now we can also check the status of the cluster. As you can see, we created a 3-node cluster right now. So what we're going to do is check the status by using this command called cockroach node status insecure, because we are testing it in an insecure mode. So as you can see here, I have 3 nodes starting on port 257, 258, and 259. So that's looking good. So I think so far all our steps are looking good. So if you want to parallelly do this, follow the instruction. It's pretty straightforward. Or if you're a multitasker, you can do it as we are continuing the session. All right, so let's do one more thing as we end this. Let's see this cluster in our console and kind of have a web UI experience. So all you have to do is click on this CockroachDB UI, and this is going to take you to a DB console. The DB console is basically our monitoring solution to monitor the cluster. And this is where you have your overview, you have your metrics, you have database information. So as you can see here, we have a 3-node cluster that is live. It's running in an insecure mode, which is fine. And as you can see, we have 257, 258, and 259. So you actually have a 3-node CockroachDB distributed SQL cluster that is running right now. And now we can go into metrics, and this is where you have multiple charts available. So we have an overview tab, we have hardware where we can monitor the CPU information, runtime information, or multiple charts to help you experience these metrics. We also have capabilities available where these metrics and logs can be pushed out to AWS CloudWatch or Datadog, depending on what your use case is. Again, we work with AWS very closely and are making more and more tighter integration. So if you have a requirement to use CloudWatch, these metrics would be available and logs would be available to be used in that platform. So there you go. So this is our monitoring console. So we have really made some good progress in module 1. And this is where we actually end module 1. You have some information available here for if you want to try this after the call as well, for you to understand what each of these metrics pages does. But for now, we will close module 1 here, and we will jump back into a session where we want you to kind of understand the key ideas of the essential elements, right? So let's just summarize what we learned in module 1. So the first thing for you to understand or remember is that all nodes in a CockroachDB cluster are equal, right? And we replicate data. That replication allows you to survive failure of nodes. And the way we have designed or architected the clusters or CockroachDB really is to enable scale and high availability. And you can design it for low latency or to handle latency between regions. We have designed it so you can kind of have a tailored experience. If you have requirements around low latencies, you can do that as well. Again, we have the applications that you are going to connect to CockroachDB will have consistent data because we have a Postgres wire compatible capability built into the product. So just wanted to summarize module 1 as we go into the next part of the session. Again, Jeff, thank you so much for covering all of that. If you have any questions, feel free to post it in the chat and we will address that. Yeah.
Yeah, so just take a pause, some housekeeping. That Killer Coda link that we sent out, that will also be available anytime after the call if you want to try it out again in your own time as well. And also, pretty easy to set up, right? The whole database. It took David, how many? 4 minutes to set up and distribute SQL data? Yeah.
It's pretty easy, yeah. And typically, I mean, this is just an environment where we are, like Harsh, you said, right? It's an terminal environment for hands-on. My experience has been when I'm trying to deploy this with CloudFormation or with Terraform on EC2, we have scripts available. We have everything available for you to set it up within like 15 minutes. And if you want to design other capabilities into those Terraform or CloudFormation scripts, you can do that as well. And the setting up is pretty easy.
Yeah, and by the way, what's even easier, dedicated and serverless. Just create an account on Cockroach Cloud, and with a click of a button, you'll get your managed service cluster up and running.
Up and running, yeah. That's the easy button option that we have available. Awesome. All right. So, I mean, if you have any questions, feel free to post it. Otherwise, we'll just go and we can address everything towards the end as well. Awesome. So let's talk about some CockroachDB essentials. So now what Jeff kind of was talking to you about and what we initially shared is all about how the architecture is structured, right? Like how the architecture of CockroachDB is. But there are some other key things that we wanted you to understand with respect to the essential fundamentals of CockroachDB. And the first thing we want you to understand is that at the highest level, CockroachDB converts SQL transactions or statements that you have into transactions that are stored as a key value pair and then distributed and replicated across nodes and stored on disk. So when you look at that statement or when you think about that, you see there are 5 different layers in CockroachDB. Then we have the SQL layer that helps convert these SQL statements into transactions. Those transactions are then broken into and distributed across the cluster with replication and stored eventually in the form of a key value. So what we want you to be aware of is CockroachDB essentially is a transactional key value store. So for somebody who's writing an insert statement, the statement would look something like this. Insert into inventory values with ID 1, which is the primary key, Apple, and say you want to buy 12 apples, right? Which is what Jeff and Harsh prefer to buy 12 apples. I'm more of a 6 apple guy. But having said that, if you have another value, you will store that as ID 2, orange, and 15. So when you actually store this into the database and when you interact, this will look to you as a table with ID 1, 2, apples quantity, and oranges with quantity 15. But really at the crux of it, at the core of it, the way we store it is as a key value where we have the inventory with the primary key of 1 stored as a key and the rest of the value stored in a separate column. So we want you to be aware that at the end of the day, CockroachDB is a transactional key value store, and that's what makes it quick, fast, and helps you have the best performance when you want to design for scale and high availability. Now, the other thing we do is really we take all of this data, we also store it in a monolithic sorted map. So every data that is coming into the database is saved as a key value, but also it's stored as a sorted map and in a lexicographic way by the key. So again, you have the order here of apples and oranges, but the key is basically a numerical. So we are sorting it in 1, 2s, 3s in that order, in that lexicographical order by key.
And semantically, you're still just querying this through SQL, Postgres, your Postgres wire protocol. So even though it's a key value stored underneath, You don't need
Yeah.
to know anything special other than your Postgres dialect.
Exactly. So the fundamental idea is we wanted to keep the experience for developers and database folks to be the same, which is what we have been learning in colleges and schools since for 20, 30 years, that is SQL. But at the lower level, this is how we really store it. So as you can see, you have all of this data of different dogs, in the name from Carl to Z. As you can see, all of this data is actually stored as a key value pair in a monolithic sorted map. And that's a fundamental idea that we want you to be aware of. And then what we do is we take this data that we have, we actually call this lexicographically sorted data. We call it key space. We take that key space and actually divide them into continuous ranges of 512 megabytes. And these ranges is essentially how we go to the next step. So first thing to be aware of, as we were saying, you have all of this data that is stored as a key value pair. It's actually sorted and kept in one order of the key, and then you actually divide this data into multiple chunks, which is what is called ranges. And then what we do is we take these ranges and we actually replicate those ranges across multiple nodes. So it's not like we take the entire data set and then send it everywhere. We actually break it in different chunks, and that allows us to have network advantages where network packets are going faster and replication happens even if one node is down, or get data quickly available to you. So the most important pillar right after the awareness of ranges is that we take that range, we break it into multiple we take the entire key space, break it into different ranges, and then we replicate that. And these replications of ranges we call replicas. And in production, typically what we recommend is have at least 3 replicas of your data. The smallest amount of CockroachDB cluster that you can put in production is a 3-node cluster, because you really want to take advantage of the replication capability for high availability and the scale that we provide. So you will have typically replicas in the form of 3 at the bare minimum, and then you can actually extend it to 5s and 7s. We recommend you have the orders of 3, 5s, and 7s, like odd numbers, basically. So what we discussed here is CockroachDB is a transactional key value store. It stores everything in a monolithic way. We break that data across multiple ranges. We then take those ranges and replicate them and push it across multiple nodes to give you that advantage of scaling fast, surviving anything, and thriving anywhere. All right. So now that we have spoken about that, let's actually go back to the killer coda and really just run some CRUD operations and actually play around with what we are saying. And to what Harsh just shared with us, the entire experience is still Postgres or SQL, right? But in the underlying form, all of these things are actually happening on the database. So we'll switch back to the killer coda environment. It'll give everybody a minute to get there, like maybe 30 seconds. And once you're there, all you have to do is click on the next module. And now we are at transactions with CockroachDB, where we're going to do running queries on CockroachDB. And actually, we're going to run a workload and observe a workload as well. All right, Harsh. Harsh, did I miss anything? Harsh or Jeff, if you want to add something while we let everyone get here.
No, I think good so far. But just, yeah, if anyone has any questions, don't be shy. Put them in chat.
Right. If you,
I mean, the only thing I'd like to comment on is I don't eat 12 apples in a sitting. So,
Yeah.
Of course.
And the other thing is I like to get my apples from Costco. So David was right about that.
Yeah. I mean,
you're
a
like
Costco guy.
105. Yeah. 105 apples.
Yeah. Awesome. All
I
right.
don't see
So
anything in the chat.
here's the thing, I mean, I know everybody's like really polite. It's lunch hour. If you're having lunch and you're also having the session and interacting with us, totally fine. Make sure if you have any questions, post it in the chat as well. All right, so let's jump back into module 2, as you can see here. And what we are going to do here is essentially in the first part of the module, we are going to do some CRUD operation, that is create, read, write, and update some data and see how that experience kind of looks like. And for me, when I started using CockroachDB, and I was using NoSQL databases for a long time, I was using document stores and I was using column value, row databases, and then realized I reached a point where I really wanted to do consistent transactions, and I could not do it in those for those use cases that I was looking at. And when I started using CockroachDB, I realized that, well, it's exactly the same paradigms that I have been used to, for such a long time, and it gives me the same experience. So here, what we're going to do is experience that by actually going into Cockroach SQL by clicking on this command. This actually takes us into the Cockroach shell, where we are going to actually run these SQL statements. And the first thing what we're going to do is create a database, and we are going to call the database game data. And let's create the database, and it's executed that. And now just let's see the database. You can see there are some databases available. So this is the default database, and game data is the database that we just created. Now we're going to change the default database to the game data database. So we're going to click on that, and now we are in game data. And let's create a table. So here I'm going to create a simple table called users. And again, when you create games, there are different users. You will have ID, you will have a username for that user, an avatar, their location, time zone, their wallet information, their email, and their display name, things like. So we just took some of those gaming requirements and put them into a user table, and that's what I'm actually executing here. And now let's do show table. When you do show table, you can see that the table has been created. And this is basically the first part of CRUD, right? That is create. And now let's insert some data. And again, we're going to click on that part, and we are implementing some data real time in the form of this user called Phyllis, and their username is ptaffley0. So that data is there. Let's execute some other inserts as well. And then I'm going to insert one more for ETH. And let's now look at this data by running select star from users. Again, the whole experience is what you're used to with Postgres and SQL here. And again, as you can see, all of that data has been, stored in CockroachDB using this command. Now let's see how a delete happens. A delete is exactly how or what you've done before. So all we'll do is delete from users where username is educate7, right? So again, we're just using that ID and that username and deleting that. Again, what you have observed here is that we didn't have to give any partition key here. We could use any of those columns, right? So we use username, and we were able to kind of delete the data. Let's go back and use this, and we can see that particular row has been deleted. And now let's go and update. Let's do the in CRUD, let's do the update. And so here I'm going to update the lang tag to en. Right now, as you can see, the lang tag is English for, is German for Merali. So what we can do is just update that. And let's go back and just run this statement and see. Again, we can see that the language tag has been changed. So this is how you can actually do just the same experience that you have with SQL with CockroachDB, but now available at scale with distribution. Anything else that Harsh you want to bring up here? I know Harsh was instrumental in putting together this data of inserts. Yeah.
Yeah, no, good overview. We'll get into more details on everything and how that actually happened here, but yeah, nothing from my side right now.
Awesome. Well, thank you, Harsh. So now that you've seen us just do CRUD operations with CockroachDB, let's run an actual workload and see how that experience kind of looks like in production. So what we have is we have this workload capability that we have built in, where we actually run a workload called mover. So that's what I'm actually doing. When I click on that, what we are doing is we are setting up some data for this database called mover. So I just did that. So this is just some temporary data. So let's go back into the database and then go into the mover database and see these are the different tables that we created for this database: promo codes, rights, user promo codes, users, vehicle information. And let's just see some of this data by clicking on this statement. And you can see we are storing ID, New York City information, name of the person, their address, and credit card information. Of course, you have ways to encrypt that information as well. But again, for this test and this sample, we have everything kind of open and showing. So now let's exit the console. And what I'm going to do now is basically run this workload like you're going to run this in production for at least 1 minute. So as you can see, I have Cockroach workload running for a minute duration. And while this is happening, let's go and observe the metrics on the dashboard. So what we have here is the portal at running on 8081. So I'm just going to click on that. This one specifically, the way we have embedded it into the workshop, it'll take you directly to the dashboard overview page. And as you can see, we ran some commands, and now because the workload is actually running, you are going to observe transactions happening and SQL statements running on CockroachDB. So you can see the SQL statements are coming. Most of them are selects and inserts, and this is going to run for almost a minute. So again, that's the whole experience. So as you're using CockroachDB, we have these metrics available. If you want to go in and just look at the SQL activity, you can actually go in and kind of check that as well in the SQL activity page. Again, the database is game data is what we created in module 2A, and the mover database is what we created through the the workload that we are running here. And as you can see, we have replicas getting created. To what I just shared, we take the data, we break them across multiple ranges, then we replicate that data. So as you can see right now, we have 102 ranges, and none of the data is actually unavailable. All of them has been distributed. So let's go back to the metrics, and we can see that the 1 minute of workload is over. So again, I mean, when you run it in production, of course, this is not going to have that dip. And with that, that's the close of module 2. Now, for you who are listening to this and who are watching the session, the observation is that you're still doing SQL statements. What is really happening underneath this system, right? What is really going on, and how is this data moving around? How is replication really happening? And that's where the I would say the main or the entree of this session is, and that's why I'm going to invite Harsh to kind of walk us through that in the next part. So if you have any questions, feel free to post them now. I'm going to stop sharing and let Harsh share his screen, and
Sure.
let's go through that.
Thanks, David. Are you able to see my screen? It should give you what we want to talk about. Looking good?
Yes, I can see it. Yeah.
Okay, perfect.
Thank you.
Yeah. So CockroachDB, right? Like, first of all, why the need of distributed SQL? And the complexities that may come with it, but what we've achieved through working through this. As you know, organizations want to modernize their applications, what they've done is they really tried to take a cloud native approach. And what they run into is even after modernizing their applications, there's a possibility because of how their applications scale and how they're expanding their business. They're still being held back by legacy databases. And to take a distributed approach, what we did was we didn't take a database that already was there, like a Postgres, and then try to modify it and alter it and make it distributed. We actually, like David and Jeff talked about it, we took it from the ground up, re-architected it from the ground up, and made it distributed to actually be easy to scale and scale consistently and still be consistent. And with that, a lot of the things, that new terminology that comes in, that especially with folks who don't work with KB stores or NoSQL or so on, CockroachDB is the best of both. It takes the flexibility, the scalability, the resiliency of NoSQL with the familiar SQL interface, the consistency of a SQL database, and combines it into one. And with that, you have these new complexities, or not complexities, the things, terminology that we like David mentioned, like ranges. And what is a range? It's basically a unit of replication, if you want to think of it at a very simplistic point of view. And why do we have three replicas of the data at a minimum? Why do we replicate it as odd numbers? We do that because we do consensus based transactions, and we'll get into that really soon. But as I set that up, now I really want to go over what is a leaseholder that I have on my screen here. A leaseholder is basically it's a replica or the range that holds the lease for that set of data. And what do we mean by that? It's basically responsible for responding to read and coordinating write requests from that come with the data that it actually holds the lease for. And how do we do read operations basically? So for read operations, like let me take a step back. I mentioned that we do consensus-based transactions. Read operations, for that, consensus is not required. How do they work? So the range that you see here, the copy of the data that you see here in the middle of your screen, that's your leaseholder. So whenever a client connects to any node, every node within CockroachDB is a peer. There's no master worker model that we have. Every node is an equal, so you can connect to any node and you're connected to the database. So as a client connects to your gateway node or your transaction coordinator, your gateway node then looks up your leaseholder and set where it is, and it sends a request to the leaseholder for that read operation. Then the leaseholder returns the result to the gateway node, like, hey, this is the result you wanted from your select statement. And at that point, the gateway node, which was interacting with the client, responds back to the client, hey, this is the data that you wanted. For this, consensus isn't required. Why? Because the leaseholder always has the most up-to-date copy of data for that range. It's the one that is always consistent. For write operations, this is where we handle all the complexities, but to understand, this is where the nuances of distributed transactions really come into play. And for this, you need consensus, and that's why you need those 3 replicas. So to start off, whenever a client connects to any node within the CockroachDB cluster, let's say the gateway node here, it looks up the leaseholder similar to how it did in the read request, and it sends the write request to the leaseholder. From there, what the leaseholder does is it sends the write request to the other replicas of the same range as well. The leaseholder not only updates its own copy of the data as it's sending out the write request to the 2 remaining copies, it also waits for one of the copies or one of the replicas to acknowledge that they've also completed a write in their range. At that point, what the leaseholder does, it notifies the transaction coordinator or the gateway node wherever the request originated from, that with an acknowledgement that the write is complete. And the gateway node then responds to the client, and the remaining replica can be updated a few milliseconds behind. We'll get to why that is okay in our next slide. But the reason behind that is consensus. At that point, when did we give the client that the acknowledgement the write was completed? When a majority of our replicas or the ranges were updated. So that ties into the quorum-based or consensus-based transaction philosophy that we have in maintaining strong consistency within the database. Because the last range is updated even after sending the acknowledgement that the write was completed. The reason that's okay is because it's not responsible for any read requests. Those read requests are always going to go to the leaseholder. So even though that the last one is eventually consistent, that's okay because it's never going to handle any read requests that come in. It's always going to start with the leaseholder. Now, how do we handle node failures? Now, CockroachDB, the reason it's called CockroachDB is because we can survive anything, right? So let's say a node failure happened with a node that did not hold the leaseholder, did not have a leaseholder. So the reads, continued to be unaffected, and since the leaseholder is still available, what happens is, as you see here, that node, it got deleted, it failed. All we need to do is we need to add a new basically add a new replica to the remaining nodes that are available to the cluster. And the reason that it's okay and the cluster did not see anything in terms of a node failure, which we'll also demonstrate live in a later module and how that's handled, is because you still have a quorum, you still have a majority of your data still, those replicas still available. So as you noticed, if I go back a bit, you, if that was removed, you still have 2 out of the 3. You have consensus. So that's why it's still the database can still serve transactions without any downtime. It can still serve read requests, write requests, because we're not at a state where you have a single point of failure and we can't lose any more copies of the data, and we're still able to maintain quorum, we're still able to maintain consensus. Now in a scenario where we have a node failure where the node failed which was holding the leaseholder. So because we implement the Raft protocol for consensus within the cluster, the leaseholder, if it goes down, it's detected by the Raft protocol. So what happens at that point is a new leaseholder from the remaining replicas is elected first. So that is usually going to be, as the copies of the data are updated during requests, we know which all the copies are going to be consistent. And from there, one of those copies is going to be elected as the new leaseholder. And eventually, from the remaining nodes that are available, a new copy is basically replicated into the remaining nodes. So that way, not only are you able to not have your cluster down and not be able to ultimately serve transactions, but through the Raft protocol, not only are you automating how that the new leaseholder is elected from the remaining copies, you're also automating the task to keep quorum within the database at all times as well. So that's why, CockroachDB, like as a user, you don't have to worry about this. This is all automated under the covers. It doesn't really go down. It's hard to kill, and we'll see that soon in David's next workshop module. Yeah. So let me go to the next slide. Slides.
Thank you, Harsh.
Yeah, my slides are not working anymore, but perfect time.
Yeah, I think we gotta be the demo gods, All right. Hopefully you can see my screen now. All right. So so one of the key things that Harsh shared with us right now was this idea of how do we do node failures, right? How do we handle that particular scenario when you have a distributed system and you have applications writing to your database and something happens and the node is not available. So for the last like 40-50 minutes, Jeff, Harsh, and I are saying that, well, Cockroach is not going to create a problem and you're going to have an experience where your users are going to feel like nothing happened. So let's test that scenario out. Or are we just just doing like fake selling here, right? So let's test resiliency with CockroachDB. That's going to be module 3. So what we're going to do here is really test that bit out by really bringing down some nodes. So let's go to module 3, and in module 3 we are going to actually kill a node while a workload is going on. And then what we are going to do is we are going to add another node and get everything back to normal. So that's what we're going to do. So the first thing we want to do is just let's go back to the console and let's see like a really healthy cluster. We have 3 nodes, 257, 258, 259, right? Everything is looking great. Life is awesome. For anybody who is in site reliability, this is the dream. Things working fine, no tickets, no issues. Life is perfect. So what we're going to do now is create some problems for them who are trying to monitor the cluster and make sure everything is up and running. What we have is I have this kill statement where I'm actually looking at port number 257, and I'm going to kill the node that's running on port 257. So as you can remember, we started 3 nodes, and these 3 nodes are running on 3 different ports. So we'll kill the node that's running on port 257. All right, so let's just pass that command. And as soon as we passed it, what you're going to see is, oops, something happened, right? Immediately there is an effect. Seems like this node is not working properly. So what we'll also do is create a scenario where we'll run the workload for 3 minutes. So I'm running the mover workload. Now it started running. So as you can see, transactions are really happening. But what's essentially happening is that these transactions are going towards the other two nodes that are available. But to you, who's the user, the experience is, well, it's running. There's no problem, except for somebody who's actually monitoring the cluster. Things are really bad, right? So let's go to port. Let's go to the other node, which is running on port 258 with port 8082, which is the HTTP address on which we can see this console. And let's see that, okay, there is something really wrong right now. There's one of these nodes that is not working. So if you go into metrics, we can see that transactions are happening. The production workload or this test workload really is going on, and it's running pretty fine actually. But for some reason, there is this one node that has died or is in suspect state. So typically, what happens is the nodes really stay in suspect for a certain amount of time, and if it doesn't come back, the console will declare that it's dead. Like the cluster of nodes after a certain point are aware that this node is not coming back, so it'll declare it dead. Right. So right now it's suspect, and it's going to move to a dead state. So that's where you're actually seeing an experience where you have workload going on in production or in a scenario where you're having all these reads and writes. And again, you can see that these are different tables that we created through the mover database, and all of this data is actually going in and out, and all of these transactions are happening. But for some reason, the cluster is working fine. Of course, it's got one node down and one suspect, but everything is working perfectly fine. If you go back, there are some under-replicated ranges and things like that. That's happening because one of those nodes is not available. So now we have brought something down. Let's bring it back to a state where everything is working fine. So let's go to the next page, and what I'm going to do is create another tab here. And what I'm going to do, let's actually stop this workload. That's going to keep it easy and keep me in the same path. And now what I'm going to do is actually start that node again that's just running on 257. So we'll just click on that. And this node is getting started. And we are basically restarting the node. And this is a scenario that happens all the time. If something happened, say storage disk got full, or you have no log space available, and suddenly the server goes down, things happen, or connectivity issues can happen if you have multi-region setup, or within different availability zone you have connectivity issues. Anything can happen. This is a scenario that we are all used to in this distributed world of data transactions. So this can happen. And again, let's now go back to port 8082, and everything is back to normal. As you can see, 257 is back up, and anything and everything that was written to the database while that node was down has been updated to that new node, and data has been distributed, and you're back up and running. So if you are a site reliability engineer, or if you are somebody who has to manage a lot of throughput, a lot of transaction, all these things happening in your world with your application, and you have mission critical applications that have to be available all the time and have to scale, you're looking at a solution that helps you experience that. So if you're doing game purchases, or you're trying to do authentication for your gamers, all of that can now be experienced through a CockroachDB. Now, we have been talking about the database itself, but how does this really apply in the context of a game, right? Like that's the most important part. You're a company who is creating game tech use cases, or you're creating a game. How does all of that really work? So in module 4, which is actually a bonus, what you will see is we'll actually get to play an actual game that our team really designed for this build a session. And what I'm going to do is, the game is actually called Cockroach Lab, and and if you, I'm just going to bring that game up so everybody can actually see the game. So I'm just copying that. Give me one sec. All right, so let's just open it here. So this is the Cockroach Lab game that is coming up, and the team here was instrumental in bringing this game together. When you bring the game up, you will hear some music, and that music for the game is written by Jeff, uh, who's on the call, who in his past has been a great thrash metal, heavy metal music guy, and had a band and a lot of long hair. So so he put the music for all of us for the game. But this is the Cockroach Lab game. So to the slide where we were talking about an experience where you have gamers coming online and playing the game, we're going to do that live right now. And what I'm going to do is go to online, and I have an account that I've created. I think Harsh, we might have to like update the gaming server just to make sure. Okay. And for the game server, what we are using is we are using Nakama, which is one of our game servers that we are using here. And as you can see, when we go into the accounts page, we have Harsh, my account, and .cockroach, which is actually Jeff's username. And we have actually created our accounts in the game. And as we go in and kind of log in, we are now looking for a multiplayer game right now. So what I'm going to do is click on match. And while we are looking for a match, let me go and show you that this Nakama console, this game server, is actually connected to a CockroachDB environment or a CockroachDB database. This database is called the Nakama test environment. But what you are going to see here is that we have this default database, and within this default database, I have different tables where the game is going to get served. By the database. So we have the users table. One of those tables we actually created in the workshop. So you have this table, and this is the tables, the description, all the things that we're storing, like username, display, avatar, language, and all those other information. And as we go back, you can see that the match is set up. Harsh, Jeff, and I are on the game. I'm just going to click I'm ready. And what we're going to do is actually kind of play it out for you. And if you are actually playing this game with other folks on the call today, you can actually do that by clicking on a match. And as you can see, we have a paper roll to kill cockroaches. But the whole idea is this is a distributed lab, and we are competing for supremacy. So let's just finish a round and let's just beat each other up. All right. So let's
That's
see
not
who wins.
fair.
All right. So, well, there you go. Harsh actually won that round. So we actually can see a leaderboard here. The leaderboard here is Harsh. Well, I was playing with papers when Harsh switched to guns. So this is a real experience, right? When you're actually playing this game, and right now I'm in Texas. Jeff is in the Northeast, and
I'm in San Jose.
and Harsh is in San Jose. We really played this game with super low latency because we are actually running this in an environment where everything is working perfectly. But to what you're seeing here is the experience of a game, the game that is getting connected to a game server, which is Nakama. And within Nakama, you can see all of this data. We have a leaderboard information, all the other status that you need for the game to run properly. And all of this data is actually stored in CockroachDB. So let's see that information. So here, what I'm going to do is actually log into this database, the Nakama test database that we've created. And this form of the database that you're seeing run in console is actually the serverless CockroachDB environment, which Jeff was talking to you about. So again, we have three ways to deploy our CockroachDB product. One is you can self-host it on EC2 instances, or you can run it in a dedicated fashion on cloud, such as AWS, or you can run a serverless database that will run on, AWS as well. So now I have logged into the database, and what I'm going to do now is just show you some of the things that I was talking about. So let's see the tables. These are all the different tables, and let's look at the table statement that I showed you. This is exactly the same thing that you can see on the console. So the way that we've created the console is to avoid going into the command line. There are a lot of things that you can do here as well to make sure everything is working fine. You can provide privileges and things like that also from here, or what are available. You can see the grants. And now let's do this. Let's actually look at some of the data actually that's stored on the database. So as you can see, Harsh, my, and Jeff's information is available here. Again, this is how we are providing this experience. Now, what you just saw here is just usernames, right? But when you're really running a game, you have to look at the console. You have to look at leaderboard. You have to look at purchases, subscription, what device you have, what is the user's edge information. If they're using a wallet, like if you're into crypto, some games have the ability to connect through their MetaMask wallet and do transactions through that. So there are different things available, and you can create that for your game or any particular game tech use case around identity or authentication, all built into this environment. So again, this is what we wanted to show you, like a real game, running on a game server with CockroachDB. And just if you want to really see the architecture of how this can be done in AWS, right? And what you really would have is an experience where you have a bunch of users connecting from different locations that connect to a Nakama server. And the Nakama server is which is a game server that will allow you to do matchmaking, authentication, allow you to experience leaderboard and multiplayer experience. And all of that data is actually served by, data across multiple zones. So here in this example, I have US East 1, West 2, and Europe. So ideally, with Route 53 capability on, with geolocation policy, you would see that users who are in Europe will be connecting to the Europe side of the database and will get data through there. And the way distribution happens and the way we have architected everything, this will run smoothly. So what you just saw is this, architecture in a live with that experience. So just wanted to kind of bring everything together that we have been talking about game tech through this architecture and this game that we have been talking about. Now, I just want to be cognizant of the time. We know we decided to like go on for an hour 30 minutes. If needed, we have more time. I'm just going to pause here before we go uh, into the quiz or like the call to action, and just see if there are any questions that you would like us to address. I know there some of you are asking questions on chat, and we are answering them. But if you have any more questions, feel free to unmute or ask questions. And Gabriel, I know you are also listening in, and if you have any questions, we would be happy to answer it for you. All right. So with that, we'll just keep it here and see if we have any questions. Harsh, any questions or any thoughts that you would like to add?
No, I think all good. And apologies if my presentation cut out at the end. My computer literally crashed and I had to jump back in.
Awesome.
Yeah.
All right. Let's see. So yeah, I mean, I would say all these modules that you have seen here, these modules are available. If you really want to play the game, module 4 is a bonus available. You can actually click on this link and access the game and kind of play, go to online, create an account. You have to actually just create a fake account because it's just testing. And then you can, play this with at least 2 or 3 players. And these are the functions to play the game. So, we will have this environment. We'll have the game running for a bit, after the session is done. If you want to like experience it, once again, I would like to kind of thank you for taking the time to hop on to this game tech session with CockroachDB and AWS, and I hope this has been a great builder session. We'll just, in the interest of time, skip over the quiz and go straight to next steps. If you have liked what I've shared or what Harsh and Jeff have shared, there are ways to connect with our team and there are resources available, right? Please feel free to contact Jennifer Casey, who is our AWS Alliances Manager, for anything that you need help with in terms of getting to connect with our team or your particular account. If you have any technical questions, feel free to reach out to me, or you can also get help from Gabriel, who's on the call, and he will help us connect. We have some resources available. We will share these resources out to everybody who joined the call today. We have some of our courses available on our Cockroach Lab University. You will have links available where you can create an account and actually go through a little bit more deeper experience of all the different functions and capabilities and features that Cockroach Labs offers through CockroachDB. We also have an O'Reilly book. The latest book is available through this link. You can connect with us through the Slack community. You can also have access to a bunch of webinars where our CTO and CEO have come and spoken about, the origins of CockroachDB and the way we look at the landscape of, or the evolution of distributed SQL in this decade. We also wrote a game tech white paper that is really helpful if you want to understand how you can start designing things with CockroachDB. So that white paper will also be shared with you. And along with the Dev Sister story, we are also going to share with you a couple of other case studies for Hard Rock Digital and Heroic Labs. Heroic Labs is a company whose game server we just used. That was Nakama. And I actually host a Cockroach Labs led podcast called Big Ideas in App Culture, App Architecture. So feel free to hop on to that podcast where we talk about all the buzz around databases and all the amazing things that are happening in technology. So if you would like to connect with us and if you like to come on the podcast and talk to us, we would be happy to. So feel free to reach out to me and we can have that lined up and connect with you through the podcast as well. So with that, I would say our time is up. And again, once again, thank you for hopping on to watch this build a session and for your amazing interaction on the call. So thank you again. Gabriel, I will hand it over to you.
Yeah, David, Harsh, Jeff, thank you so much for putting this together. This was an amazing presentation. We look forward to, working with you again and hopefully having many more events in the future. Thanks everyone today for attending. We will work to put this video up on our YouTube channel. So if anybody wants to have kind of a second pass at it, it will be available there. And that's it. Enjoy the rest of your week and have a good one. Thank you.
Everybody.